Every kernel of corn contains vitamin B3. Your body needs it to survive. But in raw corn, that vitamin is locked. You cannot absorb it. 3,500 years ago, the Aztecs found the key. They soaked corn overnight in water, mixed with crushed limestone. A single soak unlocks the vitamin, softens the kernel, and kills the toxins inside. When Europeans brought corn back in the 1500s, they transported the seeds but ignored this technique. Called it superstition. For 2 centuries, hundreds of thousands of people sickened from a disease that never had to exist. So how does a vat of lime turn corn into chips? And today, can you find the answer in one word on the bag long before written language? Mayan ancestors grew teosinte, a weed with tiny kernels, looking nothing like modern corn. Over millennia, they crossbred it into maize. But raw maize had a problem, a hard hull and nutrients trapped inside. So they developed nixtamalization from the Nahuatl word nextli, meaning ashes, and tamale, meaning unformed dough. They boiled the kernels in water mixed with wood ash. The alkaline solution dissolves the hull, swells the starch, and softens the hard kernels. They ground it into a wet dough called masa. From masa came tortillas, tamales, and the foundation of a cuisine. This knowledge was passed down from mother to daughter over 100 generations. No paperwork, no textbooks, just hands and memory. In 1493, Columbus brought maize across the Atlantic. In a few decades, corn spread across Spain, Italy, France, Egypt. It grew fast, yielded high, and fed millions of people. But no European recorded how to prepare it. They planted the seeds and ignored the soaking step. By the 1800s, a disease swept through every region where corn had become a staple food. Doctors called it pellagra. Symptoms followed the 4 Ds: dermatitis, diarrhea, dementia, death. In the American South during the Great Depression, 250,000 cases and 7,000 deaths per year, all just because no one asked the people who grew it how they actually cooked it. It was not superstition. It was the chemistry of survival that Europe had rejected. Today, lime vats run on an industrial scale, but the chemistry hasn't changed. It starts with dent corn, a starchy variety with a small dent on the top of each kernel. Not sweet corn. Dent corn has more starch and less sugar, providing a sturdy crunch for chips. The kernels go into steel vats filled with water and food-grade calcium hydroxide at a concentration of 1 to 2%. The mixture heats up to about 80 degrees Celsius, then soaks for 12 to 14 hours overnight. The factory floor smells like wet limestone and warm cereal. Earthy minerals. Nothing like the finished product at all. During that time, the calcium hydroxide does 3 things at once. 1. It breaks down the hemicellulose, the glue holding the hull together, so the skin peels off like wet paper. 2. It converts bound niacin into free niacin that your gut can absorb exactly the vitamin Europeans lost when they skipped this step. 3. And it destroys mycotoxins, specifically aflatoxin, a mold toxin linked to liver cancer, cutting contamination levels by 90 to 94%. The calcium itself binds to the kernel, increasing the calcium content by 750%. A single soak, 4 transformations. The next morning, Workers drain the alkaline liquid and wash the kernels in clean water until the pH drops to neutral. What remains is nixtamal. Earthy smelling and mildly sweet. Not like raw corn at all. You can smell the difference. Raw corn smells sharp and grassy. Nixtamal smells warm like wet stones after the rain. It goes through a stone mill. 2 volcanic stone discs spin in opposite directions and it becomes masa, a warm dough with a texture like wet clay. Press a finger into it and it holds its shape. Squeeze it and it's pliable. For chips, masa mixed with extra water is pressed through steel rollers into a thin sheet about 1.5 millimeters thick and stamped into triangles. The triangle shape is not decorative. The 3 points distribute force evenly across the chip, so it holds up when you scoop heavy salsa without breaking in half. The raw triangles drop into oil at 180 degrees Celsius for about 60 seconds. The surface starches dehydrate instantly, creating a hard crust while steam escapes from the inside, creating the small air bubbles you see on the surface of the chip. The Maillard reaction kicks in. Amino acids and sugars recombine at high temperatures, turning the chip golden and emitting a roasted nutty aroma that fills the entire production line. Still glistening with oil, the chips pass through a curtain of fine salt. Timing is critical. The salt only sticks when the oil is still wet on the surface. Wait 10 seconds too long and the salt bounces off. Then they cool on a vibrating conveyor belt and drop into bags filled with nitrogen, not air. Nitrogen prevents oxidation and cushions the chips during transport. From kernel to sealed bag, about 36 hours up to 14 hours of which is just soaking. What started as leftover tortillas fried in a pan became one of the biggest snacks on Earth. In the 1940s, Mexican and American cooks in Los Angeles started frying misshapen tortillas that were supposed to be thrown away. By 1966, Frito-Lay launched Doritos from a small food stand inside Disneyland. The name means little golden things in Spanish. Today, the U.S. tortilla chip market exceeds $10 billion a year. Frito-Lay controls nearly 60%. Americans eat over 4 billion pounds of chips, a year more than 12 pounds per person. The entire industry started from the 2 cheapest ingredients on Earth, water and lime. But do you know the most ironic part? The food you call Mexican food was never invented in Mexico. Traditional Mexican kitchens serve tortillas, warm and soft, fresh off the comal. Cutting them into triangles, frying them crispy and sealing them in bags is completely Mexican-American, born in immigrant kitchens where nothing went to waste. And the country that exports the most tortilla chips is not Mexico. It is the United States, shipping a product built upon Mayan chemistry back across the border, from indigenous knowledge to corporate profits. From mother to daughter's hands for 100 generations to automated assembly lines. From clay comals to industrial fryers. The same chemistry, a completely different scale. And who owns the story? But the strangest detail of this story still hides on the back of the bag. Pick up a chip, just a small triangle, practically weightless, sitting between 2 fingers. But that chip traveled a very long way to touch your hand. It started as a hard kernel, locked tight in a hull that your body couldn't break down. Then, one night, soaking in lime water changed everything. The hull peeled off. Vitamins unlocked. Toxins disappeared. The kernel became dough. The dough became a thin sheet. The sheet became a triangle. And 60 seconds in hot oil turned it into what you are holding right now. Next time you open a bag, flip it over, look for the word nixtamalized in small print. It sits quietly among the other ingredients. Easy to overlook, but now you know what it means. You know it carries the weight of a 3,500-year-old technique, a forgotten pandemic, and the hands of every woman who passed it down without ever writing it on paper. You bite down. The crunch, salt dust on your fingertips, a 3-second chew, 3,500 years in a single bite. Europeans called it superstition. 3,500 years later, we call that exact same thing food science. One word on the bag, a single soak changes everything. From survival to industry, from sacred to secular, from maternal knowledge to machine knowledge. But the chemistry never changes. Calcium hydroxide still breaks down the hull, still unlocks niacin, still kills aflatoxin, still saves lives. The 1500s or 2025, nature's laboratory or a steel factory, the same process. Today, nixtamalization is not just for chips, masa for tortillas, tamales, arepas, pupusas. The entire Latin American cuisine is built upon it. But in global processed foods, this technology is still underrated. Most industrial corn ignores nixtamalization. Corn flakes, no. Cornmeal, no. Corn syrup, no. Polenta, no. They process corn without unlocking the vitamins. The pellagra lesson is forgotten. Profit beats nutrition. Fast beats good. Some companies are starting to highlight nixtamalized as a selling point. Organic brands, craft tortilla makers tell the story. They charge extra for the ancient process. Premium positioning, but the irony. What was once the standard for 3,500 years is now marketing. What the Maya did every night is now a premium option. Progress going backwards. We have to rediscover what our ancestors already knew. So the next time you are at the store, read the bag. Look for nixtamalized. It tells you the vitamins are unlocked. It tells you the toxins are removed. It tells you someone knew the chemistry, no matter what they called it. And if that word isn't there, you are eating unfinished corn, safer than pellagra, because modern diets are more diverse, but more nutritious. No, still locked vitamins. Still wasted potential. One word on the bag, a difference you can see if you know where to look. That is the process. We reveal how things really work, one story at a time, from a tiny corn kernel to a billion-dollar empire, from indigenous knowledge to corporate laboratories, from survival to a snack. 3,500 years, one word, one soak. A difference between sickness and health, between locked and liberated. The Maya knew, Europe forgot. We are relearning. And every time you hear the crunch, you are hearing the echo of hundreds of generations saying, "We figured it out. We passed it down. Now it is yours." If there is anything you want us to explore next, let us know. Until then, trust the process. Thailand is not only a country possessing many famous resort tourist destinations, but also has many modern industries exporting to Europe. One of them is the canned corn manufacturing industry. And today, we will explore together the process from cultivation to production of these canned corn cans. Thai sweet corn grows perfectly in fertile alluvial lands in the central region, with a tropical monsoon climate. Ideal temperatures of 75 to 90 degrees Fahrenheit, and rainfall of 40 to 50 inches per year. The main season is from November to February of the following year, a cool, dry season, perfect for corn to develop sweet kernels. From sowing, it only takes 65 to 75 days for the corn to ripen, twice as fast as many other crops. Each hectare can yield 12 to 18 tons of fresh corn, amazing productivity. Caring for sweet corn is an art. After sowing seeds into soil beds 6 to 8 inches high for good drainage, seedlings sprout after 5 to 7 days. Farmers use water-saving sprinkler irrigation, needing only 15 to 20 inches of water throughout the season. NPK fertilizer is applied in 3 splits immediately after sowing, when the plant is 12 inches tall, and when silking. The special thing is that sweet corn is very sensitive. It must be harvested at the right milk stage time when the kernel is full of sweet water. Before the kernel hardens, only 2 to 3 days. That is the secret to delicious sweet corn. Recognizing ripe corn is a traditional skill. After 18 to 22 days since silking, the silk turns from yellow to brown. The cob swells tight. That is the golden sign. Skilled farmers peel a few leaves, squeeze the kernel. If milky white sweet water shoots out, it is time to harvest. If delayed 1 to 2 days, kernels will be hard and lose sweetness. That is why sweet corn harvesting must be extremely precise in timing. Harvesting sweet corn is a race against time. Specialized harvesters enter the field at dawn, when the temperature is still cool at 70 to 75 degrees Fahrenheit to keep corn fresh. The machine has a rotating knife system, cutting corn cobs from the stalk, a conveyor belt taking them to a large container. One machine can harvest 2 to 3 acres per hour, equivalent to 15,000 to 20,000 corn cobs. Workers follow behind, picking up remaining cobs. Speed is key. Corn must reach the factory within 4 to 6 hours to keep maximum sweetness. Immediately after harvest, trucks full of fresh corn rush on the road to the factory 10 to 20 miles away. Corn cobs are stacked carefully in crates with ventilation holes, avoiding heavy pressure. The countdown clock begins for every hour passed. Corn sweetness drops 5 to 10%. That is why Thai sweet corn processing plants are often built right next to farms to ensure perfect quality. Welcome to the production heart, the modern sweet corn processing plant. Trucks dump corn cobs into the giant receiving system. The first step is weighing and sampling. Each corn batch is weighed accurately. Taking 10 to 20 random cobs to check sweetness using a bricks meter, minimum standard 12 to 14 bricks. Kernel size and color. Only batches meeting standards are put into production. Poor quality batches are returned or used as animal feed. That is the strict quality commitment. The next step is extremely important: husking and removing silk. Corn cobs are poured onto an automated conveyor belt into the dehusking machine. The machine uses rubber rollers rotating fast at 3,000 RPM, clamping and pulling the outer green leaf layer off completely in just 2 to 3 seconds per cob, revealing rows of golden kernels inside. Then, the cob goes through the silk removal station. Automated rotating brushes brush off brown silk sticking to the cob. The entire process is automated, processing 150 to 200 cobs per minute. Now is the time to separate corn kernels, the magical stage. Corn cobs, after husking, are put into the automated kernel cutter. The machine has sharp circular blades adjusted precisely, rotating close to the cob surface, cutting corn kernels off the cob at a depth of 75 to 80%, not too deep causing bitterness, not too shallow causing waste. Thousands of fresh yellow corn kernels fall onto the conveyor belt like a golden waterfall, while the bare cob is ejected to the back for animal feed. Nothing is wasted. Corn kernels just separated still contain many impurities: leaf pieces, silk, young kernels, damaged kernels. They go through a multi-stage washing and sorting system. First, preliminary washing with high-pressure water to remove dust and light impurities. Then, soaking in a large water tank, good kernels sink. Bad kernels and impurities float and are skimmed off. Next, AI-powered optical sorters scan each kernel with high-speed cameras, removing strange colored kernels, diseased kernels, broken kernels. Only perfect golden kernels are transferred forward, passing rate reaches 85 to 90%. Now to the key step: blanching. Clean corn kernels are put into a giant blanching tunnel containing boiling water at 203 to 212 degrees Fahrenheit. The goal is to blanch for 3 to 5 minutes to inactivate enzymes causing color and taste loss, while retaining natural crispness and sweetness. This process also helps reduce 70 to 80% of bacteria. After blanching, corn kernels are cooled quickly with cold water at 40 to 50 degrees Fahrenheit for 1 to 2 minutes to stop the cooking process, keeping bright yellow color and crispy texture. From loose kernels to the perfect corn can. Corn kernels, after cooling, are automatically filled into standard 15-ounce tin cans that have been cleaned and sterilized. The filling machine is absolutely precise. Each can has 280 to 300 grams of fresh corn kernels. Error margin only plus or minus 2 grams. Then the machine automatically adds light brine, a mixture of purified water, 1.5 to 2% salt, and a little sugar to enhance natural sweetness. Fill level 90% of can volume, leaving 10% headspace for expansion during sterilization. Filling speed: 400 to 600 cans per minute. Seaming is a high-tech art. After filling, each can is immediately fed into the automated seaming machine. The machine places a tin lid on the can mouth. Then, high-pressure rollers roll the lid rim and can rim together into 5 overlapping metal layers, creating a completely hermetic seal. This process takes place in 0.5 seconds per can. Then, AI cameras check 100% of seams. Any can with imperfect seams is rejected immediately. This tightness ensures the product is preserved for 2 to 3 years. This is the step-deciding quality retort sterilization. Thousands of corn cans are stacked into large carts, put into a giant retort chamber like a giant pressure cooker, Doors close tight. High-pressure steam is pumped in, increasing temperature to 240 to 250 degrees Fahrenheit and pressure 15 to 18 pounds per square inch for 60 to 90 minutes. This high temperature kills 100% of pathogenic bacteria, including dangerous Clostridium botulinum spores, while cooking corn kernels completely. That is modern food preservation science. After sterilization, corn cans are extremely hot and must be cooled immediately. The pressure chamber is vented slowly to avoid can bursting due to sudden pressure difference. Then, cans are taken out and put through a cooling tunnel. Cool water nozzles at 70 to 80 degrees Fahrenheit spray continuously on cans for 15 to 20 minutes, lowering temperature from 240 degrees Fahrenheit down to 100 degrees Fahrenheit. Proper cooling process helps create vacuum in the can, extending product life and keeping corn kernel texture from becoming mushy. Each can, after cooling, must undergo strict quality inspection. First, the leak tester cans are submerged in water. Any can with escaping air bubbles, meaning leaking, is rejected. Then, AI cameras check can appearance dents, rust, deformation. Next, automated electronic scales cans must reach standard weight of 425 plus or minus 5 grams. Finally, every production shift takes random 10 to 20 cans sent to the lab to check microbiology, pH 6.0 to 7.0, and sensory, pass rate 98 to 99%. Standard corn cans are transferred to the automated labeling line. Inkjet machines print production date, expiration date, 36 months, batch code and barcode on the can lid with safe food grade ink. Then, beautiful colored paper labels with the River Kwai brand. Images of fresh yellow corn kernels and nutritional information are pasted automatically around the can body with absolute precision. Labeling machine speed 300 to 400 cans per minute. Finally, spraying a thin protective paint layer to prevent rust and scratches during transport. Perfect corn cans are packed into cartons. Robots stack 24 cans into each brown carton printed with the River Kwai logo at the dizzying speed of 60 cartons per minute. Automated taping machines seal the boxes. Then, lifting robots stack boxes onto wooden pallets, each pallet holding 80 to 100 boxes, nearly 2,000 cans, 5 to 6 feet high. Finally, automated stretch wrap machines wrap around the pallet to secure tightly, all ready for warehouse and export. The journey of canned corn to the world. From the factory, pallets are transferred to a giant cold storage, maintaining 50 to 60 degrees Fahrenheit, humidity 50 to 60%. The WMS system tracks each pallet by RFID and barcodes. Trucks carrying 40-foot containers arrive, each container holding 20,000 to 24,000 corn cans stacked on 18 to 20 pallets. Containers are transported to Bangkok port, loaded onto giant cargo ships going around the world: USA, Japan, Europe, Australia. Sea journey 15 to 30 days. Corn remains original quality thanks to perfect canning technology. And finally, the sweet corn can reach as global consumers. From the destination port, containers are distributed to major supermarkets like Walmart, Tesco, Carrefour, and thousands of small stores. Every day, millions of families around the world open River Kwai corn cans to cook soup, salad, pizza, or eat directly convenient, nutritious with vitamin B, fiber, and natural sweetness with no preservatives. From golden corn kernels on Thai fields, through 12 strict processing stages with modern technology, to the perfect corn can in your hand, that is the magical journey of food science and sustainable agriculture.